Hello everybody, and welcome to my part 1 presentation of what I got for IPv4 addresses. And in this video, and part 2 as well, I'll have a little quiz and answer key at the end, so we can take a look at that. Well, let's get started. So with IPv4 addresses, for the structure of an IPv4 address, basically an IPv4 address is a 32-bit hierarchical um, address that is made up of a network portion and a host portion. An IPv4 address is separated by four 8-bit fields, and each field of these 8-bit fields is called an octet. And as you can see on to the right here, each number between the dots here is each octet, and below that it shows that in a binary form. And we can see here that 1 byte is equal to 8 bits and 4 bytes is equal to 32 bits. With a unicast transmission refers to one device sending a message to one other device in one-to-one communications. A unicast packet has a destination IP address that is the unicast address which goes to a single recipient. A source IP address can only be a unicast address because the packet can only originate from one single source. IPv4 unicast host address are in the address range of 1.0.0.1 to 223.255.255.255. The broadcast transmission refers to a device sending a message to all the devices on a network in one-to-all communications. A directed broadcast is sent to all hosts on a specific network. For example, a host on the 1.72.16.4.0/24 network sends a packet to 172.16.4.255. A limited broadcast is sent to 255.255.255.255. By default, routers do not forward broadcasts. Broadcast packets use resources on the network and make every receiving host on the network process the packet. Therefore, broadcast traffic should be limited so that it does not adversely affect the performance of the network or devices. Because routers separate broadcast domains, subdividing networks can improve network performance by eliminating excessive broadcast traffic. Multicast transmission reduces traffic by allowing a host to send a single packet to a selected set of hosts that describe a multicast group. Hosts that receive particular multicast packets are called multicast clients. The multicast clients use services requested by a client program to subscribe to the multicast group. Each multicast group is represented by a single IPv4 multicast destination address. When an IPv4 host subscribes to a multicast group, the host processes packets addressed to this multicast address and packets addressed to this uniquely allocated unicast address. When it comes to public and private IP addresses, just as there are different ways to transmit an IPv4 packet, there are also different types of IPv4 addresses. Some IPv4 addresses cannot be used to go out to the internet, and others are specifically allocated for routing to the internet. Some are used to verify a connection, and others are self-assigned. Public IPv4 addresses are addresses which are globally routed between internet service provider or ISP routers. However, not all are available. IPv4 addresses can be used on the internet. In the mid-1990s, private IPv4 addresses were introduced because of the depletion of IPv4 address space. Private IPv4 addresses are not unique and can be used internally with any network. The IPv4 address range, the first one is 10.0.0.0 to 10.255.255.255. Another one is 172.16.0.0 to 172.31.255.255. And the last one is 198 or 192.168.0.0 to 192.168.255.255. And with a quick quiz here at the end here, question one is which 8-bit field an IPv4 address is called? Number two, which transmission hosts address that are in the range of 1.0.0.1 to 232. Oh, that's supposed to be 32, I believe. 255.255.255. And then number three, which transmission reduces traffic by allowing a host to send a single packet to a selected set of hosts? Number four, true or false, 172.0.0.0 to 172.15.255.255 is a range of a private IP address. And number five here, which of the following IP addresses are public or private? And 5A is 10.68.8.168. B is 164.114.34.55. C is 172.16.5.35. D is 192.168.73.155. And E is 192.0.111.5. And before we all go on to the next slide with the answer key here, I encourage that you pause the video here to get these answers, get these questions answered for yourself. And then for the answer key here, the number one was an octet. Number two, unicast transmission. Number three, multicast transmission. Number four was false. Number 5A was private. 5B was public. 5C was private. 5D was private. And then finally, 5E was public. That's all I got for your part one. And I'll see you next one in part two.